Hi students, in today's video, it will be the revision package for WA2, and we'll be doing simplifications of surds, rationalizations of surds, and solving equations involving surds. This is a rather long video with quite a few different kinds of problem solving, different kinds of problems. So it involves a little bit of patience and also perseverance. Right, so don't give up. Right, the first questions we're going to do is learn how to simplify surds. So let's look at the number 180 first. So basically 180, what are the factors for 180? You can have 2 times 90, you can have 3 times 60, you can also have 4 times 45, or even 5 times 36. Right, so why is it I've highlighted 5 times 36? Because basically when you want to simplify surds, right, we are trying to break the number into something times a perfect square. Right, if you have to recall, perfect squares are number like 4. When you square root 4, you get 2. Square root 36, you get 6. Right, so we try to convert the number to express the number as something times a perfect square. Right, then for the second number, 245, basically we know that you can just be divided by 5. It's divisible by 5. Right, so you can just try dividing it by 5 and you get 5 times 49, and 49 is actually a perfect square. So similarly for 125, we can divide by 5 to get 5 times 25, and 25 is a perfect square. Right, so we're going to put everything back into your questions. Oh, wait. So there are two rules basically in the chapters of surds. The first one is that if you have a square root a times b, basically you can just break it up into two separate terms, which is square root a times square root b. If you have a square root a over b, again you can break it up into square root a divided by square root b. And the conditions is such that both a and b must be more than 0. Because it does not make sense to have if b is 0, you can't have something divided by 0, right? It would be a what do you call that, undefined answer, right? Okay, so let's put everything back into our questions, and then we can just apply the first rule. Where you can just split this guy up into square root 5 times square root 6, and likewise for the other two terms. Okay, and we all know that square root 36 is 6, so that will give you 3 times square root 5 times 6 plus square root 5 times 7 minus 2 times square root 5 times 5. And then we're going to group all this, multiply these integers together. That will give us 18 square root 5 plus 7 square root 5, and then this one, if you multiply them, will give you 10. Alright, so you will see that square root 5 is actually a common factor. So for common factor, you can just factorize it. Right, and then 18 plus 7 minus 10 will give you 15. So usually we will write the number in front of your surds. So even though you have 15 times 5, right, the normal presentation would be the number in front of the surds. Okay, so this is how you do questions on simplifications of surds. Right, so this is also another questions where we need to simplify surds, except that it's slightly harder. Why slightly harder? Because it involves something like this. We have a square root 1 over 8. So it involves something called rationalization of surds. Right, but let's try to simplify square root 32 first. So 32, you can have a 2 times 16, and that's perfect because 16 is a perfect square, so you can just stop there. And of course, yes, you also can have 4 times 8, but we're not going to do that. Why we're not going to do that? Some of you will say that 4 is a perfect square. What? Yes, 4 is a perfect square, but we don't want to choose this because then you need to simplify 8 again as 4 times 2. So can you see, if you have to do one extra steps. So rather than doing that, if you have a 4 times 4 times 2, then the 4 times 4 will give you 16, right? So it makes sense to use 2 times 16 instead of 4 times 8. Right, so 2 times 16 is the more relevant one. So 8, the factors for 8 would be 4 times 2, and 4 is a perfect square. Okay, let's put everything back into the questions. Okay, so what happened now here is that there are two ways of doing this one. You can break it up. You can apply the second rule that we talked about earlier on, where we can have square root a over b will give you square root a over square root b. Yes, right. And square root 1 obviously will be 1. And then square root 8, we can break it up into square root 4 times square root 2. And here, this is where we need to do something extra. Okay, you see that the denominator is a surd, so we need to rationalize it. So rationalization means you make your denominator a non-surd, right? So we just, yes, so we rationalize it by multiplying it with square root 2 over square root 2. Okay, you don't have to multiply it with 2 square root 2. Basically, you just multiply with the surds. That will do. Because you are just making the surds. You only want to make the surds a non-surd. Okay, you're not so, the 2 there does not matter. The 2 there is already a non-surd. You understand? So you don't really need to worry about it. What you need to do is just to make square root 2 a non-surd. So that's why you need to multiply by square root 2 over square root 2. Alright, so you simplify further. Yes, and this is something you need to recall, that square root a times square root a gives you a, right? Just as square root 2 times square root 2 will gives you what? Square root 4, which is 2, right? Or square root 3 times square root 3 will give you square root 9, which is just 3. So therefore, square root 2 times square root 2, this one here, and this will just give you 2. Okay, you simplify further. Alright, and then you can factorize your square root 2 out, and then you have 9 over square root 2. So there's a little thing about this part here that some of you may have problem, what do you call that? Understanding that it's equals to 1/4 square root 2. So I did a little bit of, oh, hang on. I think I need to erase off so that you can see clearly. Okay, so basically square root 2 over 4, you can write it as 1/4 times square root 2 over 1. Right, because 1 times square root 2 will give you square root 2, right? Then 4 times 1 gives you 4, right? So this thing here, square root 2 over 1 is just square root 2. So square root 2 over 4 basically is just 1/4 times square root 2. Okay, right. Alright, let's look at this question here. The question says that without using a calculator, okay, it does not mean that you cannot use a calculator to evaluate things like 28 times 4 or 16 times 900, that kind of thing. When they say without using a calculator, basically they're just saying that you have to show you're working properly to get the answer. So you just can't use a calculator and then, give me the answer like 0.312, is it, or something like that. You can't do that. You will get totally wrong. So how do you go about doing it? Okay, let's try to simplify square root 28 first. So 28 is just 4 times 7. 2 times 12 doesn't give you 28. I make a mistake here. Okay, so 4 times 7, it's a likely choice. So we're just going to use it. Alright, then for 70, you can't really simplify it anymore. There's no perfect square there. So we're just going to leave it as square root 70. So the next step is that we're going to rationalize it. Or simplify first. Yeah, simplify your square root 28 first to get 2 square root 7, and then after that rationalize it with the conjugate surds. If you cannot remember what conjugate surds are all about, or simplification of surds, that I've done a video. You can go to Math with OLK under playlist, look for surds. So there are 3 chapters, 3 subtopics there. You can just choose the topics that you're not sure of, and then revise on the basic concepts. So in this revision package, I'm going through a little bit faster because I take it as you already understand some of the basic concepts. Alright, so the next thing is that we're just going to multiply numerator, multiply denominator. Alright, so one thing good about the denominator, it's, if you have to recall, if you have a plus b multiply with a minus b, you will just get a squared minus b squared, which you can just easily use a calculator to help you evaluate. That means this chunk of thing here, you can just use a calculator. Okay, there's no need to try to work it out step by step. Just use a calculator. Right, then the numerator, we're going to use distributive law. Alright, okay, so the one highlighted in yellow, use a calculator and you'll get 68. Alright, so simplify the numerator. And the square root 490, okay, this one here, again, we need to simplify it. Simplify it into one, I think it's 49 times 10. Okay, because 49 is a third. Oh my, why is okay, let's continue with the previous slides. Yeah, so square root 490. So 490 basically is just 49 times 10. Right, and then 350. 350 is just 25 times 14. Alright, so how do you know how do you know that you use 25 times 14? Right. Because if you look at the questions, the question actually does give you some hints on the final answer. So if you look at the final answer, right, one of them will be in terms of square root 10, and one of them is in terms of square root 14. Right, so basically the answer does give you a hint that how you can express your answer. So that's the reason why I take 350 to be divided by 14. Okay, and then over 68. Right, so we simplify further, apply the rules that we have learned earlier. Right, simplify some more. Right, and express it in the forms that the questions require you to do. Right, you will see that there are many different ways that they can set the questions to test you. But basically, the concepts are just simplifications of certs. All right, rationalize it, and then to be very careful with manipulations. Right. So if you can do these three things well, then you can solve any questions in this topic. So for this questions here, again, there are many ways of solving it. Some of you may go ahead and to combine this into single fractions. Right, you can do that also. Another way it's you can just rationalize this one. Okay, right. Some people may also, instead of doing that, some people may also treat this as one term, and then you open up the brackets. All right, so I'm going to, okay, before I actually show you the methods I'm using, right, if you want to combine into one single fraction, right, basically this is what you can do. The denominator will be 1 minus square root 2, right? So you will have 1 minus square root 2 multiplied with 1 minus square root 2 plus 1, and then times 1 plus square root 2. Okay, so that will gives you you need to expand these two guy up, will give you 1 minus 2 square root 2 plus square root 2 times square root 2 gives you 2 over 1 minus square root 2, and that will gives you 3 minus 2 square root 2 over 1 minus square root 2. Okay, and then you need to multiply your numerator, and then after that need to rationalize it. So it's rather long steps. If you want to do it this way, it's pretty long. I will not advise you, but I'll just show you lah. Some of you may use this method. Okay, this is pretty long because I tried it out. I tried the different methods. That's why I'm showing you the shortest method possible. Right, another method is just now what I say is that you just treat this as one term. So when you open up the bracket, will be just 1 minus square root 2 multiplied with 1 plus square root 2, and then plus 1 over 1 minus square root 2 times 1 plus square root 2. Right. So this one is your a minus b times a plus b, right? And that will gives you a squared minus b squared. So that gives you 1 squared minus square root 2 squared. And this will gives you 1 plus square root 2 over 1 minus square root 2, right? So this will give you 1 minus square root 2 times square root 2 is 2. And then you need to rationalize it. So again, this one is quite long steps. It's quite a long steps. So if you want to do that, you must be very careful with the calculations. Okay. So what I'm going to show you, it's a rather easy one. Or not really easy, but maybe I should say more efficient one lah. So what did I do here? It's just basically I rationalize the one highlighted in yellow first. I rationalize it first. Okay, you rationalize it first, and then you will get, yes, you will have 1 plus square root 2 over negative 1. So that will gives you negative 1 minus square root 2. Right, how do you get that? It's just basically you multiply with negative 1 at the numerator, multiply negative 1 at the denominator. Okay, so that's how you get negative 1 minus square root 2. And then you plug that back into your brackets. Okay, plug it back into your brackets. So this one you simplified it. 1 minus 1, this will be gone. So negative square root 2 minus square root 2 will gives you negative 2 square root 2. And then you can just multiply with this term here, the one that's just circled in black. in dark, not in black, sorry, I should not say in dark black, sorry, in dark ink. Okay, right, and then you can just open up the brackets. Okay, yeah, just open up the bracket. You will have square root 2 times square root 2 gives you 2. Okay, recall this law, and you have 2 square root 2 minus 4. And you compare your 2 square root 2 minus 4 with what you're given, because you're supposed to find the values. Here you're supposed to find, specifically told to find the values of a and b. So you compare it with your a plus b square root 2, your a will be negative 4, b will be negative 2. Right, so there are many ways of solving questions involving surds. But whatever method you choose, you just need to be careful with the manipulations, because it can be, sometimes can be quite tricky, and then if you're not careful, you'll make careless mistakes. Right, so this is another questions that you may be tested on. Right, so the concepts are pretty simple, right? The concepts are just how to simplify it, expressing surds as the number as a number times perfect square, rationalize it and things like that. So a lot of it involve your algebraic skill. Yes, algebraic skill. That means whatever you learned, managing equations, that kind of thing. All these skills are still very relevant to solving equations involving surds. For example, this question here, if you have square root x equals to 5 over 2 minus 1 over square root x. So basically, if you have a denominator that is like this one is a fraction, right? Fractions. How do you get rid of fractions? How do you change the fractions to whole number? Right. So here, this is kind of algebraic skills you've already learned earlier, right? So you will know that you just have to multiply both sides with square root x. Okay, this kind of skills is what when you learn earlier on, like solving this kind of questions, like if you have half x minus 3 equals to 3 quarter, right? How do you solve it? Right, you just multiply by 4 on both sides, right, to convert all of them into whole numbers, right? Yeah, so this skill is not new. This is what you've already learned it earlier. Right, so right, so you will have square root x times square root x give you x, and then you will to expand this bracket here. 5 over 2 times square root x will gives you 5 over 2 square root x. Basically here, this one, this and this will give you square root x over square root x, and that's how you get 1 here. All right, so you're solving it means you're finding the values of x. So I need to group all the terms involving x on the left hand side. Oh, I didn't do that. Okay, one way is you put everything involving x. Oh, I don't want to do that first, sorry, because you know why? You will see that there is a square root here. Right, so I'm not going to bring x to the other side. I can't factorize x because this is square root x, but this is just x. So the better way is just to square, bring the negative one over and square both sides to remove the square root. Okay, the purpose is to remove the square root. Okay, so when you square this term, you have to be very careful because you're not just squaring the square root x, you're also squaring 5 over 2. So basically, this is how it looks like when you square it. You have to square your 5 over 2 as well. So that gives you 25. Yes, okay, I'll work it out for you. And then this one here, you can use the beautiful algebraic identity. So useful to expand it. Right, so I mentioned earlier that 5 over 2 times 5 over 2 is 25 over 4. Square root x times square root x gives you x. Okay, and then what happened? Okay, I'm going to make it like 25 over 4 to be a whole number multiplied by 4 on the left and also on the right. And then you end up getting a quadratic equations where you can just factorize it. Right, and you will get x equals to 1 quarter or x equals to 4. Okay, both answers. You should do a substitution, but I think you should work because what you're getting is a positive number. So square root of a positive, there's no problem. If you have a negative, then you can't square root of a negative, then you have to reject it. Okay. Alright, so surds can also be in the form of problem solving. Alright, not just simplifications or not just simply rationalize it or solving for the values of x. It can be a problem sum. So I specifically choose these questions because the volume given has a pi there in terms of pi. So some students have no clue of what to do with the pi, and then they just kind of lost halfway. Right, so first thing first, we just draw a diagram. Okay, we're talking about cylinder, so let's draw a cylinder. Not a beautiful one, but you can see it's a cylinder. So let's put down the radius, which is given to be 1 plus 2 square root 2. And then, of course, there's a height, which is unknown. Right, so we need to write down the formulas to find volume of a cylinder. So by now, you should be able to remember formula to find volume of a cylinder is pi r square h. So pi and then the r is just 1 plus 2 square root 2. Make sure it's square root times height, will gives you the volume, which is given to be 70 plus 14 square root 2 bracket pi r. So this is the part that some students don't know what to do uh, with it. Okay, actually it's very easy. You just make h the subject because you are asked to find the exact value of the height h, right? So when you see this word exact value already, they give you the hint that you're not supposed to like multiply the pi, substitute the pi to be 3.142, the kind of thing. This is also, yeah, this is one common mistake some students will make because they are quite clueless what to do with the pi, and then you just times 3.14, and if you do that, that's not correct. So that was the more correct way to do it. You make h the subject, right? Then can you see that now you have pi at the numerator, pi at the denominator, and that you can just divide each other. Pi divided by 5 was gives you 1. Okay, so if so so you have to leave the pi alone, and ultimately it will cancel off. All right, so the next step is, of course, to simplify your denominator first. Simplify first, at the side or somewhere before you continue. Right, and then we'll continue at the next slide. This one here, basically I'm using your a plus, the beautiful algebraic identity again, which is so useful. So if you're still not too sure how to do that, please learn it. Oh yeah, I wrote it down also. Yeah, sometimes I cannot remember what I've written. Doesn't matter. Okay, so I see you at the next slide. Alright, so let's continue with what we have stopped at the last slide. So from here, I already get rid of my pi, and then I need to rationalize it with the conjugate surds. If I've already forgotten what conjugate surds are all about, please refer to the earlier videos I've done. Okay, look for surds under playlist. Right, rationalize it and then apply distributive law. Okay, distributive law, if you remember, just take 70 multiply with this whole chunk of thing, and then plus 14 multiply with that chunk of thing again, and then the denominator will just give you a squared minus b squared, where you can just use a calculator to work it out. Okay, and you simplify the numerator, simplify the denominator. No, denominator, just use calculator to work it out, gives you beautiful 49. Okay, this one just use calculator to work this out. Right, yes. And sometimes when they come to these steps, right, you really don't know what kind of common factor to take it out, right? The questions involve you to express it as a plus b square root something over c. A plus b square root 2 over c, right? But you don't know what common factor to take out. 518 and 154, what common factor to take out? So never mind, don't worry, you just split it into two fractions first. Yes, to split into two fractions, and then just use a calculator. You see, the calculator, it's a wonderful equipment that can help you solve a lot of things. Just use a calculator to help you, and then calculator will simplify 518 over 49 to be 74 over 7. 154 over 49 simplified to 22 over 7, right? And then after that, you combine them back into one single fraction. Okay, right? So your A basically is just 74, B is negative 22, C is 7. But I don't think you're asked to find A, B, C, so you can just leave your answer as such. Right, let's look at the next questions. Again, these questions, we are not supposed to use a calculator, meaning you just need to show your steps. Every steps, okay, and ultimately you're asked to find the values, the integer values of a and b. So after solving it, you need to write down the values for a and the values of b, and the answer will be in this format. Okay, so more or less that gives you a hint that finally your answer, the denominator, will be 17. So if you don't get that, then something wrong with your solutions. Okay, so this question is involving finding the values of x. So you see that your x is a non-surds, right? So that's the case. We can first thing first, we have to expand this one. That means we have to group all your x terms together and put it on the left hand side. It's different from the one we've done earlier on. The one we've done earlier on, there are some the x, some of them is in a surd, some is not non-surd, right? So you can't put them all together. Okay, you have to square both sides to remove the one with the surds one. Here it's all right because all your x terms are non-surds, so we can put them everything on the left hand side. Okay, this is what I mean. Group everything on the left hand side. Yes. And what happened here is that I rewrite this. I prefer to write positive first. So I will write it as square root 5 minus square root 3. Okay, so you can see here that the common factor is x, so we can just factorize it. Okay, so this part here is really involve your algebraic skill. Okay, it sort of doesn't really involve anything with surds. It's your algebraic skill that you pick it up along the way. The next one is the one that really involves surds because you need to rationalize it. This is where you need. So a lot of things is that whatever you learn is built on, okay, of whatever you've learned early on. It just keep building on. It's like a building blocks like that. You know, like Lego, play Lego, keep building on. All right. So similarly, apply distributive law to the numerator. Square root 5 times. I prefer to use a distributive law than the one, a lot of students like to cross here, cross there. I find crossing here, crossing there are very, what do you call that, very prone to making careless mistake. But if you were to write it out properly, in forms like that, it will remind you, like, for example, this guy here, it remind you need to change the sign. So I prefer the distributive law than the cross here, cross there. Then the denominator, just use a calculator to work out. Okay, don't be too difficult on yourself. Don't be too hard on yourself. Whatever you can use calculator, go ahead and use it. All right. Okay. All right. And then and then simplify further. Then square root 100 will be 10. 10 minus 3 will give you 7. Okay, the one highlighted in yellow. And then this one here, 60. The factors will be 4 times 15. We use 4 times 15 because 4 is a perfect square. Alright, so that's not the end of the answer because you're supposed to find the values of A and B, right? So you need to compare this with what is given. That means you compare 7 minus square root 15 over 17 with this. And from there we find that A is 7, B is 15. Okay. Okay, bear with me. We're coming to the quite to the end of it also. I'm also losing a bit of steam already. But that's brace on. So for this questions is involving surds. Alright, so please don't do things like that. Okay, you don't do things like that. All right, you can't just say that you square it and then it becomes 7x minus 5 and then you go and square this thing. Okay, it's wrong. Okay, this is a wrong concept. Okay, if how do you know it's a wrong concept? It's very easy. Whatever you do, right, you just simply substitute x to be some number and then you see whether it works or not. If it does not work, then whatever you are doing is wrong. Like for example, some people will tend to say that square root x squared plus 16 will give you x plus 4. So I always advise the student, right, just substitute x to be some number. Let's say you substitute x to be 4. The left hand side, what you get will be like 4 squared is 60. 60 plus 60 is 32. You go use calculator, work out this value. Then the right hand side, x plus 4. Okay, we substituted x to be 4, right? 8. So you see whether these two answer the same. If they're not the same, means the method you use is wrong. You see, so that's why math sometimes is difficult in the sense is that you have to follow some rules. You cannot just use your own rule. Okay, right? But if you use the rule correctly, then most of the time your answer will be correct. Right, so what do we do with this? Yeah, it's actually not difficult. We just need to bring this guy over to the right hand side, and then the next thing is just to square both sides. Okay, this one now you can do it. You can square both sides now. Right, so what is happening is here, when you say square root both sides, means you are just taking this thing, multiply with itself again. That is what it means by square both sides. So if you were to recall, the square root a times square root a will give you a, right? So when they square both sides, this square root sign will just be gone, leaving only my 7x minus 5. Okay, I need to erase this. Yes, and of course that one you have to use a algebraic identity to expand it. Right, and then the rest is just simplifications, and then you end up with the quadratic equations where you can just factorize it, and you'll get two answer. Okay, so here I'm a little bit lazy. I didn't really show you the, what do you call that, the validations, because when you square something, right, sometimes you get some answers that's not relevant. So by right, what you should be doing is you have to substitute x equals to 2 into your original equation, into this. You can actually you don't really need to show out the working lah. You can actually just use your calculator, and see if you can equals to 0 on the right hand side. 7 times 2 minus 5 minus 2 minus 1. Yes, you get 0 on the right hand side. So this answer is okay. And then the next thing is that you can just substitute your x to be 3. And then you also get 0 on the right hand side. So this answer is okay. So if it's not okay, right, you just put bracket reject, not applicable. So you don't really have to show out all the workings to do the validation. Don't need. You just have to use a calculator, as what I've said earlier so many times. Calculator, it's really a very good equipment that can help you to do a lot of things. Okay. Right, let's look at the last questions. The last questions is a very interesting questions. It appeared to be like difficult, but actually it's not. Basically, you just keep removing the square root symbol, that's all. So the first thing is you just remove the huge square root by squaring both sides. Yeah, then before you square again, right, before you square again, so this is the part that, okay, the first part is most students can do it. Then the second part come to here, if you continue to square both sides, right, that is where you start to make mistake. Yeah, so this part here, the second line will test how good you are with the algebraic manipulations. Okay, you don't square both sides again. You have to do a little bit of thinking. All right, so what is the thinking that you need to do? Yes, before you square both sides, we need to take this guy 13, bring it to the right hand side. Okay, so basically you only square both sides when you just have one huge square root sign here, just one huge square root sign. Okay, then you just square it. And negative times negative will give you positive, right? So what is left is just 2x squared plus 7x minus plus 12. And then negative 4 times negative 4 give you 16. So again, you end up with a quadratic equation where you can factorize it. And you have two answers. Okay, we always assume that if your answer is negative, you'll be rejected. That's not quite true, okay? That's not quite true. So therefore, one of the answer is wrong. Both answers are accepted actually, because when you substitute x equals to negative 4 into the original equation, this is original equations, I actually can get 3 on the right hand side, which is valid. And also when I substitute x to be negative, x to be half, I also get right hand side to be 3. So therefore, both answers are accepted. Okay, both answers are accepted. Oh, I make a mistake here. This one should be x equals to negative half or negative 4. So sometimes we always make a mistake that we always think that negative means the answer is not correct, it's not true. You have to substitute back into the original equation, okay, to check whether if it's valid or not valid. Okay, in this case here, both answers are accepted. Right, so before we end of this video, I'd like you to look at this motivation quote again. Okay, so happy solving.